Good morning, students. In this session, I am going to start the Unit 5, that is Non-Parametric Methods and SVM Classification. So, before going to discuss about different algorithms in this unit, let us discuss what are these parametric and non-parametric classification. How we are going to define a machine learning can be summarized as a learning function f that maps input variables to output variables. Simply we say that y equal to f of x. And how an algorithm is going to learn this mapping function is from the training data. And we don't know that the form of the function. And as a our job as a machine learning practitioners is to evaluate these different machine learning algorithms, and we have to see which is better at approximating the underlying function. So generally, these machine learning algorithms are divided into two types. One is parametric machine learning, and other one is the non-parametric machine learning. A learning model that summarizes data with a set of parameters of fixed size, independent of the number of training example. So when we have a data with set of parameters of fixed size, then we call it as a parametric model. And it doesn't matter how much data we throw at a parametric model, it won't change its mind about how many parameter it needs. So that is what we call it as the parametric machine learning. An example of this parametric machine learning includes logistic regression. Already we discussed in the unit 4, linear discriminant analysis, perceptron, Navy Bayes also we already described in unit 4, and then simple neural networks. Coming to this non-parametric machine learning, these are good when we have a lot of data and no prior knowledge is required. And we need not to worry too much about choosing just the right features. So it itself will, when we have a lot of data and doesn't require any prior knowledge, it itself will choose the given parameters. And easy to understand this non-parametric model is the K nearest neighbors. In this unit, we are going to discuss that KNN algorithm also, that make predictions based on the K most similar training patterns for a new data instance. And the other examples of these popular non-parametric machine learning algorithms are KNN, decision trees, which we are going to discuss now, and support vector machine. So in this unit, we are going to discuss all these non-parametric machine learning, that is KNN, decision trees, and the support vector machine. That's why this unit we generally named as non-parametric machine learning algorithms. Coming to the very first algorithm of this non-parametric machine learning, decision tree classification algorithm. So as the name itself indicates classification. So whenever it is a classification, we know that it comes under supervised learning technique that can be used for not only for classification, even for regression problems also we can use the decision tree, but mostly it is preferred for solving the classification problems. So as the name itself indicates, it is a tree structured classifier where a particular tree contains internal nodes that represents the features of a data set, branches, it represents the decision rules, and each leaf node represents the outcome. And in decision tree, mainly there are two nodes, which are the decision node and the leaf node. So what are these decision nodes are? These are used to make any decision and can have multiple branches. And whereas leaf nodes are the outcome of those decisions, and we need not to contain any further branches. When it reaches leaf node, we need not to contain any further branches. So what is a decision tree? Already discussed, it is a supervised machine learning algorithm used to build both classification and regression models in the form of a tree structure. This is what the important thing in decision tree. It is going to have a tree structure. So when it is a tree, we know that there will be three important things in a tree, that is node, branch, leaf. And when it comes to decision tree, that node generally we call it as a feature or an attribute where we are going to get it from a data set. Branch is a decision or a rule, and leaf is an outcome. That outcome may be categorical. When it is categorical, if it is a classification algorithm, the outcome is a categorical or continuous. When this decision tree is used for regression, the outcome is the continuous. It is called a decision tree because it looks like a tree and it starts with the root node. This is the root node, which expands on further branches and constructs like a tree structure. So you can see these are the decision nodes, that is branches. These are the root nodes and these are the leaf nodes. So if it is a classification, you can say it is yes or no. Like this, it is going to give the class labels. And in order to build this tree, we use one famous algorithm. It is called as the CART algorithm, where it is abbreviated as classification and regression tree algorithm. This is the most one famous this decision tree algorithm. Then why we use decision trees? So there are various algorithms in machine learning, but choosing the best algorithm for a particular data set is the one main point while we are creating a machine learning model. So these are the two reasons why generally data scientists prefer this decision trees. Decision trees usually mimic human thinking ability while making a decision, like how we will think as how a human being will take a decision for a particular problem. Even decision tree also usually mimic human thinking. That's why it is easy to understand. That is the one point. And the logic behind the decision tree can be easily understood. Why? Because it shows like a tree-like structure. And coming to the terminologies, every algorithm in machine learning, it is going to have its own terminologies. So coming to the decision trees, these are the some of the terminologies. One is the root node, that is where the decision tree starts, and it represents the entire data set. Okay. And the next one is the leaf node. Leaf nodes are the final output node. And once we reach to leaf node, it cannot be further divided. Then splitting is the process of dividing the decision node or root node into subnodes according to the given conditions. And coming to the branch or subtree, a tree formed by splitting the tree is the branches or subtree. And pruning, we know that the pruning is nothing but the process of removing the unwanted branches from the tree. Parent or child node, this is a root node of the tree is called the parent node, and other nodes are called as the child nodes. Then coming to working of this decision tree algorithm, we have some steps. The very first step is we are going to begin the tree with the root node. Let us say that it is an S, which contains the complete data set. So this is our step one. Coming to the step two, find the best attribute in the data set. We know that we are going to have n number of attributes, that is features. So in that, we have to find out the best attribute. For selecting the best attribute, we are going to use a method called as attribute selection measure. And then we are going to divide the S it into subsets that contains possible values for the best attributes. Then we are going to generate the decision tree node which contains the best attribute. After finding the best attribute, we are going to generate a decision tree which is containing the best attribute. And we are going to recursively make new decision trees using these subsets of the data sets created in the step 3. This process will continue until a stage is reached where we cannot further classify the nodes, and that works. These are the 5 steps we require. And coming to the uh, attribute selection measure, in the very second step, we are saying that we have to choose the best attribute. That is, while implementing this decision tree, the main issue arises is how to select the best attribute. We have n number of attributes. From that n number of attributes, which is the best, choosing the best attribute. So to solve such problems, we have a technique that we call it as the attribute selection measure, or simply we call it as an AS. Sorry. By this measurement, we can easily select the best attribute for the nodes of the tree. And for that, there are 2 popular techniques for this attribute selection measures. Those are called as the information gain and entropy. So the 2 techniques a decision tree algorithm is going to use is information gain and the entropy. Let us see what do you mean by this information gain and the entropy. Coming to this information gain, it is the measurement of changes in entropy after the segmentation of a data set based on an attribute. That is, it calculates how much information a feature provides us about a class. This is the important point. So it provides an information how that particular feature provides about a class. And according to the value of this information gain, we split the node and build the decision tree. And this decision tree algorithm always try to maximize the value of this information gain. And a node or attribute having the highest information gain is split first. Why? Because it will become the root node. So how we are going to calculate this information gain is, it is equal to entropy. Entropy is S. What is S here? Entire data set. Okay. In the steps only we said that S is the entire data set minus weighted average into entropy of each individual feature. Okay. So this is the formula. How we are going to find out the information gain. So for that, first we required entropy. Let us see. First of all, how we are going to find out the entropy. So entropy is a metric to measure the impurity in a given attribute. It is going to measure the impurity and it specifies randomness in data. So how we are going to measure or how we are going to find out the impurity in a given attribute is, it is given by entropy of whole data set is given by minus probability of S log of base 2 probability of S minus probability of no log of base 2 probability of no. And where S is the total number of samples in a data set, P of S is probability of S and P of no is the probability of no. So just you have to remember this formula to find out the entropy of a given set. So once you know entropy and the information gain, the highest value with the information gain is going to take it as the root node. That is a very important step in the decision tree algorithm. So what are the advantages of this decision tree? First thing is, it is simple to understand. Why? Because it the same process how human will follow while make decision. In the same way, decision tree also will do. And it is useful for solving decision related problem. And it helps to think all the possible outcomes for a particular problem statement what you have chosen. And there is a less requirement of data cleaning compared to the other algorithm. And coming to some of the disadvantages, decision trees contains lots of layers, means depending upon the problem statement, sometimes it makes complex. And it has an overfitting issue. If the number of decision trees, the trees internally, if the decision tree is being increased, chances are there that it may goes to overfitting. And it can be resolved using the random forest algorithm, which is a combination of all these decision trees. And if you have more class labels, then the computational complexity of the decision tree may increase. So these are the some of the advantages. Now, next coming to the decision tree algorithm, that is ID3 algorithm. We have various decision tree algorithms, but we are the most popular and the most used algorithm is the ID3 algorithm, that is iterative decommatizer 3, commonly known as ID3, and it is invented by Ross Cleveland. So the steps in this ID3 algorithm, the steps in ID3 algorithm are, the very first step is we are going to calculate the entropy of a data set. So we already find out what is the, we have seen the entropy of a data set, that is minus P of S log of base 2 P of S minus P of no log of base 2 P of no. So this is the very first step we have to do, calculate entropy for data set. And for each attribute or feature, we need to calculate entropy for all its categorical values. And at the same time, we have to calculate the information gain for the feature. Yes, once you know this entropy, we can easily find out the information gain. And find the feature with the maximum information gain. Yes, once you have found out for each feature, the information gain, the feature with the maximum information, we have to find out the feature which is having the maximum information gain. And we are going to repeat this process until we get a desired tree where we reach to the leaf node where it can't be further splitted. So these are the steps in this ID3 algorithm. So we will discuss this ID3 algorithm with one example with simple data set, and we'll find out how we are going to calculate the entropy and information gain of a particular data set. Thank you.